No.
Okay, we started the video capture late. We're currently doing problem 2 of section 5-6, and we're about to write down the final answer if we can remember what it is. So it's going to be C1, 1 e to the 2t plus C2 times 1 t plus 1 e to the 2t. Yeah, I should have parentheses around that, which I didn't. Yeah, I have them up there. All right. So now, all right. So now we're gonna plug it all in. So x of t would be C1 e to the 2t plus C2 t e to the 2t plus C2 e to the 2t. And I have two separate solutions. So the other solution would be C1 e to the 2t plus C2t e to the 2t. And that guy goes away. So that would be my final answer to number 2. And then I'd ask myself, if that were the case, then would it check? So x prime of t. So we're going to check it. X prime of t would be 2c1 e to the 2t plus c2, 3c2 e to the 2t plus 2c2t e to the 2t. C2, C1 e to the 2t plus C2 e to the 2t plus 2C2t e to the 2t. And now is x prime equal to 3 minus 1, 1 x. So that's the issue. So if I have 3 of the top guy that I can't see, 3 of this one minus 1 of that one, if I were to do that, do I get this? So 3 of this one minus 1 of that one, that gives me 2 of them, that gives me 2 of them, that gives me 3 of them. So that checks, the first part checks. And then I've got 1 of the top guy and 1 of the bottom guy. So if I take 1 of the bottom guy, I get that. 1 of the bottom guy, I get that. 1 of each of those, I get that. So my work checks. I know it's hard to believe, but check, it works. Okay. So we should probably quit doing the 2x2s and start doing the 3x3s. No? We should stick with the 2x2s? Okay. So you're trying to tell me I got lucky on the first one and I should continue doing only the easy problems? Okay. So we're going to look at number 4. X prime equals 3 minus 1, 15 x. I'm going to have to solve for eigenvalues. So I got 3 minus lambda minus 1, 15 minus lambda. I'm going to take the determinant of that and set it equal to 0. 3 minus lambda, 5 minus lambda, minus a minus 1. Okay, so I got 15. I got minus 8 lambda. I got plus lambda squared plus 1. So I got lambda squared minus 8 lambda plus 16 equals, I can factor that, lambda minus 4, lambda minus 4. So my eigenvalues are 4 and 4. I have 2 of the same. And I'm supposed to have 2 of the same because I'm in this section where I'm getting 2 of the same, right? Okay, so first thing I want to do is find A minus lambda, if I can make a lambda, A minus lambda I. Okay, and lambda is 4. I'm going to have minus 2, minus 1, no, minus 2. 3 minus 4 is not minus 2. Minus 1, minus 1, 1, minus 1, plus 1. Something like that. So I got minus 1, minus 1, 1, 1. Okay, that's what we got. Okay, now we want that guy squared. So I got, maybe I should write it down. 1 minus 1 minus 1, 1, 1. Minus 1 minus 1, 1, 1. Okay, so this row times that column looks to be 0. That row times that column looks to be 0. This row times that column looks to be 0. The whole damn thing looks to be 0 again. Shit. Anyway, that's what it looks like. Okay, so A minus lambda I squared V2 has to be 0, meaning that V2 can be anything at all. We're going to choose 1, 1 again. Okay, because that looks pretty simple. Okay, now we're going to go and look at A minus lambda I V2, and that's going to be V1, but it has to be linearly independent, so we can't have the same stupid thing. All right, so A minus lambda I is minus 1 minus 1, 1, 1 times 1, 1 is going to be minus 2, 2. Wow, minus 2, 2. That's good. So we can choose V1 to be minus 1, 1 because we don't have to have the constants in there. They're both divisible by 2, so we can bring one out. Okay. Did I do that right? Yes, I did. Okay. So now I know that. Now I know that x1 of t is going to be v1 e to the 4t, and x2 of t is going to be v1t plus v2 e to the 4t. Okay, and then turn the page. I find that final answer, x of t is going to be c1 x1t plus c2 x2t. Okay, so x of t is going to be, okay, I forgot what v1 and v2 is. Okay, so v1 is minus 1, 1, and v2 is 1, 1. All right, so x is going to be minus c1 e to the 4t plus minus C2t e to the 4t plus C2 e to the 4t. And then on the bottom we would have C1 e to the 4t and plus C2t e to the 4t plus C2 e to the 4t. Okay, did I do that right? Yes, it appears I did. Okay, so that would be our final answer. But now we'd have to check our work. So we go and say, well, x prime of t is going to look like what? Minus 4 C1 e to the 4t. Okay, I've got minus C2 plus 4 C2. So that's going to be plus 3 C2 e to the 4t minus 4 C2t e to the 4t. And on the bottom I got 4 C2 e to the 4t. I've got 1 plus 4 more makes 5 plus 5 C2 e to the 4t plus 4 C2 t e to the 4t. So that's what that kind of look like. Okay. Now x prime is supposed to be a, which is 3 minus 1, 1, 5, x. Okay, so do 3 of these minus minus 1 of those equal the guy on the bottom. Okay, so 3 of those minus 1 of those, minus 4. 3 of these minus 1 of them, minus 4. 3 of these minus 1 of them, it does. Does 5 of the top guy plus 1 of the top guy plus 5 underneath equal the bottom guy? Minus 1 plus 5 is 4. Minus 1 plus 5 is 4. Minus 1, let's see, 1 plus 5 is not 5. Shit.
3 minus 1 is 2.
You sure 3 minus 1 is 2? Don't know? I didn't think so. Alright. So I didn't get 5. How come I don't have 5? 5 minus 1. I have that guy. But this guy's clearly 6. That guy's clearly 6. This guy is 4. But this guy's not 3, you're telling me? So I got 3 of those. No, 3 minus 1 is minus 4. 3 minus 1 is, there's a 2 sitting there. That's what you're telling me. But there's not a 2 sitting there. All right. So it does not check.
The last term is not a problem.
I didn't do my derivative on the bottom right.
Well, you didn't do your x and t right.
This guy here?
Your x and t, the original's wrong.
Here?
Yeah.
I wrote it down wrong?
Yeah.
Alright, so I've got 1 of those guys. I got 1 of that guy. I have 1 of this guy. I don't see how I wrote that wrong. You're saying this guy here on the bottom's wrong.
According to the back of the book, yeah.
Alright, well it probably is.
That last term, C2 e to the 4t, should be non-existent.
This guy shouldn't be there?
Right.
Wow. That means I have to have a 0 here. How can I have a 0 there? be 2. Well, I could have a 0 there because I could have picked it with a 0 there. And if I picked it with a 0 there, I would still have the same guy here, right? So if I had a 1, 0, that would still multiply out to minus 1, 1. I wonder how we would know that's a 0. That might be because it's defective. Might be. Okay, well, we'll let that mystery stand, and we will go to problem number 8, which shouldn't take me any longer than the rest of my natural life, right? And then we can go home for the day. Number 8. How far am I supposed to get? I'm only supposed to get to like 12. So if I do 8 and 12, we'll be done for the day. Okay, so x primes equal 25, 12, 0, minus 18, minus 5, 0, 6, 6, 13. Okay, so I wrote the problem down right. Did I not? Alright, so I want A minus lambda I to determinant set equal to 0. That's what I want. It's nice to want things, right? So I got 25 minus lambda, 12, 0, minus 18, minus 5, minus lambda, 0, 6, 6, 13 minus lambda. Okay, so that's what I have. So I got 25 minus lambda, minus 5 minus lambda, 13 minus lambda, 0, 0, 0, 0, minus. So I'm coming up this way. 13 minus lambda, minus 18, 12. And I'm supposed to let that be 0. This is where having a graphing calculator would really be helpful. I just have a TI-36 in my pocket. But I do have Maple, and Maple would probably tell me the right answer here. Well, so I got 25 minus lambda, 65 minus 65 minus 8 lambda plus lambda squared minus. Well, the minus is good. Okay, minus. Okay, so we got 18 times 12. 200, no, that'd be plus. Plus, no, that'd be minus. I was right the first time. Minus 216 lambda plus times 13. 2,808 is equal to 0. Isn't that marvelous? I've got minus lambda squared plus lambda cubed, minus lambda cubed plus 8 lambda squared plus 65 lambda. Then I've got plus 25 lambda squared minus 200 lambda minus, anybody know what 65 times 25 is off the top of their head? 1625 minus another 216 lambda plus 2808. Alright, so I got minus lambda cubed plus 25 plus 13, right? 33? 33 lambda squared minus 315 lambda plus 1183 has to be 0. Now luckily my new fancy less than $20 calculator will let me solve polynomials of a third order. Isn't that lovely? I know you'd like that. So I'm going to put in a minus 1 of 33, a minus 135, and a 1183. I'm going to hit solve. And I get that lambda is equal to 20.4, 6.3, and another 6.3. Now what does that mean? Well, that means that we messed up someplace, because clearly they're going to have to be whole numbers, right? Otherwise it wouldn't be in the problem. Where?
Instead of 315, put 350.
Right here?
I'm gonna try something.
You mean I did that wrong?
I think so.
65, all right. 65 minus 200 minus 216. Well, that might be helpful. 351. All right. Back to solving my polynomial again. Okay, so minus 1 is correct. 33 is correct. Minus 351. And that got to solve. Alright, so my eigenvalues are going to be 7, 13, 13. Isn't that wonderful? See how that works? Now I could have, well, there's no way I could have done that in my head, right? I can't even factor 1183. It's not divisible by 2 or 3 or 5. So I would have had to think about 7. Okay, so what we're going to do first is we're going to go case 1. Lambda 1 is equal to 7. Because we know that the eigenvectors have to be linearly independent. So if I find the guy that's separate first, and then I find that the square thingy is 0, 0, 0, 0 again, I won't pick this guy by mistake and have to redo it. Okay, so back to which problem are we doing anyway? 8? Okay, so minus 8. So I'm on A minus lambda I V1. I'm going to send that, it has to be equal to 0. Okay, so I've got 27 minus 25 minus 7 is 18, right? So I got 18, 12, 0. I have minus 18 minus 12, 0. And I got 6, 6, 6, 6, what? 5? No, 6, 6, 6. 6, 6, 6. I don't like this problem already. I don't like it already. I can tell. All right, so V1 is equal to 0. So by inspection, what's V1? All right, so if I take 2 of this one and 3 of that one and 1 of this one and put a minus sign there, Is that going to work? 2, 3, 2, 3, 2, 3. Yeah, that's going to work. Okay, so I got my first eigenvector. Excellent. I am just so happy for me. All right. So now I'm gonna look at my second guy, which is 13. Case 2. Case 2. 2 is equal to 13. Okay, so I'm going to look at a minus lambda I squared. Okay, so 13. 13, so that's 13 from 25 is how much? 12? Okay, so I got a 12, 12, 0. Got a minus 18, 0. I got a 6, 6, 0. And I'm going to square that. 1, 2, 1, 2, 0. Minus 18, 0. 6, 6, 0. Alright. This row, that column. Okay, so I got 144. Wish this calculator did matrices. Unfortunately, it doesn't. Okay, so I got 144 minus 12 times 18 equals minus 72. Minus 72. That row, this column. That row, this column, minus 72. That row, this column, 0, 0, 0. Okay, now at this point, it doesn't matter what the rest of this guy is. Okay, so we're gonna say, now why doesn't it matter? Because I don't want it to. So the square guy times V1, V2, right, times V2 has to be 0. Okay, so V2, because I have all zeros there, V2 can be 0, 0, 1, and that's perfectly okay. And that's why I don't have to do the rest of those, because that will give me 0. And that's linearly independent to my other guy up there. All right, now we got to solve for V3, even though it says V1. So I'm going to take A minus lambda I, V2. Shit. That won't work, will it? Because that says the other V1 is going to be 0, 0, 0, which is a trivial solution, which we know we can't have. So now I got to go and fill out the rest of those things and find a different V2. And I thought I was going to be so smart, but no. All right, now, that times that. So 12 times 18 minus 18 squared, knowing that I'm going to have to put a positive on it, 108. That times that, 108. That times this, that times this, 12 times 6 minus 6 times 18, minus 36, minus 36. Okay, well, that being the case, V2 can be 1 minus 1, 1. In fact, it could be 1 minus 1, 0 for that matter, if we wanted it to be 0. But we're gonna have 1 minus 1, 1 as our V2. Okay.
1 minus 1.
They like 1 minus 1 0? Oh, so we'll try 1 minus 1 0 because that's what the author thinks we ought to take. Probably because he put it in maple before he solved the problem. Now, we want to look at A minus lambda I V2, and that's going to give us V3, even though it doesn't say V3 in the book. That's what we're looking for. All right, so I've got 12 minus 18, 0. 12 minus 18, 0, 6, 6, 0, times 1 minus 1, 0. Yeah, that's what we have. Okay. No, it's not. No, it's not. This is the problem with only being able to see a little of the board. So 12 minus 18 minus 18. Is that right? 18. What did I do? Okay, no, that's fine. That's good. Yeah, I got it. Okay, okay. So I've got 0, 0, 0. It can't be that. Huh? It can't be that because it can't be 0, 0, 0. That would be a trivial solution.
Minus 3, 0, 1.
So V3 is minus 3.
No, for V2.
Oh, V2?
Does that work out?
Minus 3, 0, 1. No, it wouldn't work out for V2. Now, your V2 and my V2 and my V1 and the author's V1 could be different things.
That's true.
Okay, so are you talking about the vector with the t in it? Or are you talking the vector with the e to the 7t in it?
17.
So e to the 7t guy, I had 2 minus 3, 1.
Yeah.
All right, so that's not these V1 and V2s.
Right.
These are the other two guys.
Yeah.
But in any event, I'm hosed here because these guys wipe out to 0.
0, 0, 1, let's try that.
0, 0. Oh, yeah, 0, 0, 1. Yeah, that works perfect. Wait a minute. 0, 0, 1. V2. Yes, V2 could be 0, 0, 1. But if V2 is 0, 0, 1, then this would still be trivial. So V2 can't be 0, 0, 1 either. Huh? All right, so what are you looking at anyway that's holding me over here? Number 12.
You're listening to me.
Okay, we're doing number 12.
8.
Well, that's good because number 12 is really hose. All right, so I got the eigenvalues right. 2 minus 3, 2. So that's right. There is no t guy. So what they're saying is that this V2 is 0, 0, 0, which I would never have picked. But if he's 0, 0, 0, and I put that here, I get 0, 0, 0 for the other guy. So how does that work? Wow. Oh, it's not 0, 0, 0. C2 and C3 Okay. But there's no t's in the problem. There's no t's in the problem. Okay. Wow. Yeah. Okay. Boom. Boom. Check the real solution manual. Open. Solutions 14. No. Math. What chapter are we in? 5? All right. And we're looking at 5, 6, number 8. And so 5, 6. 5, 6, number 8. So we did that. We got that. We got this. 0, 0, 1 and minus 1, 1, 0. But how did C2 get no T?
They all have a T right next to it. See that T in the top right corner of it?
Yeah, that's just a transpose thing, so I can write it that way instead of having to write it up and down.
But there's a T right there, so they all have a T.
I don't see any C1T though. I don't think this solution's going to work. I don't think you did it right. Find a non-zero. Find 2 independent solutions, x1 and x2. And then it's going to be C1 x1 plus C2 x2. Yeah, I don't see that at all. Remind me not to ever show anybody this video again. Well, at least I got the eigenvalues and I got the first eigenvector.
You're not posting this one to the online class?
Probably not. Let's see. Where's my Maple program? See, Maple has a eigenvalue solver in it. So, file, open, yeah, we'll open that guy. Yeah, so all we got to do is just that. Copy. File, new. New. Thank you very much. New worksheet. Control V. Alright, so what's our problem? 8. Okay, so we want a 25 minus 18 a 6. And we want a 12 minus 5 6. And we want a 0 0 13 Alright, so enter, enter. Doesn't that just piss you right off? Yeah, yeah. Yeah, it really does piss me off. Now, you notice there's no T's in that solution? None whatsoever? Control, copy, Control V. We're going to do the same thing with number 4, which we had T's in, right? 3, 1. And minus 1, 5. There's no T's there either. How do you expect to get the right answer in Maple if you can't even get T's in your thing? Okay, it's after 4 o'clock. Time to start another problem. Hopefully we'll be better off. I'm not sure what the situation there was, but we clearly were hosed over really bad. Okay, so we'll do 12. Oh yeah, look at 12. Isn't that great? That looks good. 12 minus 1, 0, 1, 0 minus 1, 1, 1 minus 1 minus 1. Okay, so we want a minus lambda I, the determinant equal to 0. So I'm going to have minus 1 minus lambda, 0, 1. 0 minus 1 minus lambda, 1. 1 minus 1 minus 1 minus lambda. Now this guy might be able to do in my head. Who knows? Minus 1 minus lambda, minus 1 minus lambda, minus 1 minus lambda, 0, 0, minus 1 times 1, minus 1 minus lambda, minus, so that'd be a plus 1 plus lambda, and the other guy's a 0. Those two look like they cancel each other out. So I got minus 1 minus lambda cubed, and I know that that's going to be 1 plus 3 plus 3 plus 1, right? So that's going to be lambda minus lambda cubed plus 3 lambda squared. Well, no. Silly me. That means that has to be equal to 0, which means lambda is equal to minus 1, minus 1, minus 1. Now the issue would be, does the author give us a way? Yes, he does. He does tell us how to do this. And on the order of 1 to 10, it's a giant pain in the rear end. Okay, because we have multiple eigenvalues. Okay, generalization. N minus I, blah, 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 blah. Multiplicity 2, link chain 2, rank 2, ordinary vector, blah, blah. Okay. All right, so we have to do it again. Okay. So we have to go and take A minus lambda I cubed to be V3. That's what we have to do. Okay. A minus lambda I, blah, blah, blah. Okay, so that's the original guy. Lambda's going to be that. Okay. I'm on 12. Okay, so I've got minus 2, 0, 1, 0, minus 2, 1, 1, minus 1, minus 2, and I want to cube that. Okay, well, I guess we'll just have to do this. What do you think? I think that's the only way we're going to get the answer this side of my birthday would be to do this. Now, how come it's not in red? Okay, so we want minus 2 minus 2 0 1, and then we want 0 minus 2 1.
1 minus 1.
And then we want 1 minus 1 minus 2. Okay. 2. Oh, minus 2. Okay, so does that look right? Then we want that thing cubed. Thank you very much, Maple, for your kind consideration. A cubed. Well, that was marvelous. That was much better than I was going to do it. The only thing I was going to do is get it wrong. All right, so I got minus 14 minus 6, 12. Minus 14 minus 6, 12. 6 minus 2 minus 12. 6 minus 2 minus 12. And 12, 12 minus 8. 12, 12 minus 8. And that times V3 has to be 0. And we're going to do this by inspection. Okay. So V3 is equal to if we go 4, 4, 12, that won't do it. All right, so that's a bad guess. If we go 4, 6, 2, 4, 6, 2, that's not going to do it either. What was wrong with 4, 4, 4 anyway? 4, 4, 12. What's wrong with 1, 1, 3? 1, 1, 3 works. 1, 1, 3 does not work. 1, 1, 3 does not work. That's what's wrong with 1, 1, 3. It doesn't work. Oh. What's this? It's problem number 12? Huh?
Good luck.
Oh, gee. Oh, thank you very much, author. Now, what is the V3 guy? Okay, now the V3 guy. Oh, bummer. Okay. Yeah, you're absolutely right. One of the eigenvalues is 110. One of the values is 111. Maybe. T squared. A half, a half, and 0? I don't think so. Everything there is divisible by 2, right? I wonder if that would, if we divided everything by 2, I wonder if that would help any. Now, 14 and 6 is minus 20. Who? 0, 0, 0? That's a trivial solution. I would never pick it. 0, 0, 0 does work. I wonder if Maple would solve it for us. Solve. that guy times V1. Oh, it won't do that. It's not going to do that.
Scroll up and look at what's dragging back and copy what's above. Why?
It's not going to do that. Equals 0. Equals 0 for V1. It's not going to do that because we haven't defined V1 as something that it's going to like. Yeah.
Scroll up and copy what's above and let's solve the eigenvector line.
Well, yeah, that'd be easy though. I mean, we don't do. Yeah, I mean, we could verify the back of the book is right. Oh, wait a minute. You're right. Yeah, then we wouldn't have to need one. Okay, gotcha. All right, so we come up here and we copy that. And we paste it here. And then we copy that. And we paste it there. And we come up there and go boom, boom. You gotta be kidding me.
I told you 0, 0, 0.
You got it. That's not the answer they have in the back of the book. I just know it's not. Do we even have the eigenvalues right? The eigenvalues are -2. We said the eigenvalues were -1.
They are -1. Maple's wrong.
So we solved the wrong problem? We solved the wrong problem.
No, we didn't.
No, yes we did. We solved the wrong problem. This is a 1. This is a 1. Don't tell me we didn't solve the wrong problem when we solved the wrong problem.
Actually,
All right, now we're...
negatives in the second column, and then positive in the middle of the third.
Okay, this guy here.
That was fun.
It was good.
This guy here. Oh, this guy's positive.
Yeah, and then the bottom of the middle column is negative.
All right, so which one is that? That guy's right. That guy's right. This guy has a... That guy's positive.
And then the third one is the second bracket.
We still got it wrong? 1, 0, 1. 0. Oh, that's a minus guy there. How do I have it right? Thank you. Thank you so much, Maple. You're just so helpful today. Yeah, I don't think that's right. Yeah, that would mean if Maple's right, then that would mean that our answer is x1 is equal to c1 e to the minus t, and x2 is equal to c1 e to the minus t. And then nothing else in the equations matter. And x3 is 0. Right? x3 is 0. Boom, 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 boom. C1 times the eigenvalue. Yeah, and that's not what's in the back of the book anyway. Well, I guess we've messed around with this long enough. Why don't we try No, we're not going to do that. Let's look at the next section. Maybe it's easier. Oh, the next section's easy. Oh, yeah. Oh, the next section is so cool. The chances of me getting something right in the next section is way up there. Way up there. I remember that section. It was all, that section was always good to me. This section, I really don't believe that I can't solve a problem in this section, other than the 2x2s. Oh well, could be worse. Should we go home? Time to go home? Okay, so the plan for next class period is to finish 5-7, do a problem, get a problem, at least one problem right in 5-7, and pass out the chapter 5 test, for, which will be a take-home test, unless you want to take it home today. You want to take it home today? Okay. And then we have chapter 6 to do, and then we'll be all done.
She already had to do once. It's just going to be
Well, it's gonna be some easy note taking class.
So what will probably get to work from that?
The 2x2s.
Say again?
What homework probably get to work from that?
The ones that are assigned.
You know they are.
Well, I'd have to look. Let's see. Section 5-4, 1 through 21, odd. 5-5, yeah, 5-5, 1 through 7, 5-6, 1 to 13, odd, and 5-7, 1 through 9, odd. Shouldn't take you any more than the rest of your natural life. So we didn't do 5-4 today?
No, we did that last time.
Okay, so 5-5 and 5-6 today.
Yeah.
Well, maybe 5-5. 5-5 and 5-6. Oh, the answer to the question, it's a 5x5 matrix for anybody who has a 90 or above average in the class, and a 4x4 for anyone who has a less than 90 in the class.
A 4x4 or
Yeah,
5x5.
4x4 or 5x5. And there's no multiple eigenvalues, so it's very simple to do.
I was the answer for them.
Hmm? Nothing.
If you have above the 90, it's a 5x5.
Yeah. Yeah, for those who have above a 90, then it'll be a 5x5. And those that have,
Whoever does that, it's a 4x5.
yeah, whoever has less than a 90, they only have to do a 4x4.
Yeah.
And you only have the weekend to do it. It shouldn't take you any more than a half hour.
Yeah, right.